We will solve example 4.10 from the book Applied Thermodynamics. Mecon candidated stroke. Steam at 7 bar, dryness fraction 0.96 is throttled down to 3.5 bar. Calculate the change of entropy per unit mass of steam. So the steam that is given P1 7 bar and the dryness fraction x1 that is given 0.96. Is throttled down. It means expansion is taken place, but enthalpy in this expansion will be remain the same, that is P2, the final temperature, that is 3.5 bar. Calculate the change of entropy, so we need to find the change in entropy. Solution: if I draw the this process on a TS diagram, that what it says in statement. P1, this is the low pressure line, that is P2. So initially the pressure P1 that is at a in wet regions, so after expansion when it takes place, it will be obvious that it will be in wet regions again. So this is state point 1 is within the wet region, and when its expansion takes place, its dryness fraction will decrease and reach to the point 2. So at this point the entropy will be S1, and at this point S2 the entropy will be S2. This is the TH diagram for this example 4.10. I hope you understand it. If you are still confusion, you can ask in the comment section. Now at 7 bar from the saturated steam table, we can see that the entropy is G1 that is given from the steam table. We see that is 6.708 kilojoule per kg. Okay, and SF1 value, that is here it is 1.992 kilojoule per kg. Okay, so if you subtract this SF1 from SG1, you will get SFG1 that is equal to 4.716 kilojoule per kg Kelvin. Okay, next we need to find its entropy at the state point S1, because we are interested to find the change in entropy. So this S1 will be equal to SF1 plus X1 dryness fraction and SFG1. So after putting the values, you will get the S1 value. So SF1 is 1.992 plus dryness fraction 0.96 into SFG1, that is 4.716. So after simplifications, you will get that the S1 value that is equal to 6.522 kilojoule per Kelvin. This is our first requirement that we have successfully find it, that is S1. Next is the enthalpy at the state point H1 that we need to calculate, because that enthalpy at H1 will be equal to H2, because the process is throttled down, and throttled in the process enthalpy at first stage and final stage will be the same. So now from this saturated steam table, at 7 bar, the HF1 value is, that is 697.2 kilojoule per kg. Hg1 value from the saturated steam table, that is 2764 kilojoule per kg. Okay, now subtract this as HF1 from this Hg1, you will get that is HF G1 that is equal to 2067 kilojoule per kg. Next we need to determine the H1 value, that will be equal to H2. So the H1 value will be equal to HF1 plus dryness fractions and HFG1. So put the values, corresponding values, 67.2 plus dryness fraction 0.96, multiply with 2067 and you will get the H1 value, that will be equal to H2, and that is, after simplifications, you will get that is 2682 kilojoule per kg. Now this enthalpy at H2 state has been determined, and the pressure at P2, that is 3.5 bar. If you see that the 3.5 bar is not available in the steam table, for that we need to determine the enthalpy for the 3.5 bar saturated value, Hg2 value and corresponding Hf2 value. We will use interplotting formula to find its Hf2 value and Hg2 value. So for state point 2 at 3.5 bar, remember this 3.5 bar is lie within between 3 bar and 4 bar pressure. So the pressures, we need to find the entropy Hg2 from this saturated steam table, that will be equal to so apply the interplotting formula, that is Hga plus Hgb minus Hga divided by Pb minus Pa. So multiply with the P2 minus Pa. Here I am writing the corresponding value from these steam tables, so you can clearly understand how you will use the interplotting formula. The Hga value is 2725. This is 2725. I am not writing the units, just writing the values. And Hgb value, that is 2739 kilojoule per kg. And the pressure Pa, as I already told you, the higher value is used for the subscript A and the lower value is used for the subscript B, and put that values in the corresponding interplotting formula and you will get the required value for which you are using the interplotting formula. So the Pa, the pressure Pa, that is 3 bar, and for pressure Pb, that is 4 bar, and the pressure P2, that is 3.5 bar. I will use this formula, interplotting formula, for Hg2. The similar interplotting formula will be used and same method will be used to find the Hf1, Sf2, Sg2 value as well. You have to understand this formula clearly. If still you have confusion, you can ask, but I hope you will understand and there will be no confusions remain, because if I do every time the interplotting, the video become very lengthy and the student then gets bored. Now the Hg2 that is equal to, what is HEA? That is 2725 plus HGB, that is 2739 minus 2725 divided by PB, that is 4 minus 3 into P2, that is 3.5 minus 3, and when you simplify that, you will get the Hg2 value, that is 2732 kilojoule per kg K. Similarly, you will use the same interplotting formula, just change the variables that is need to determine is HF2 value. So after interplotting and putting the values from and getting the values from this associated steam table and put that in this interplotting formula, you will get the HF2 value. I am writing the final answer that we get from the interplotting, that is 583.2 kilojoule per kg K. So next thing, we need to find the dryness fractions at this state point 2. So how you will calculate that? It's very simple. So the entropy at state point H2 is calculated already. So the dryness fraction H2 will be equal to H2 minus HFG2 divided by, that will be equal to HF2 divided by HFG2. And what is this HFG2? It is the difference of this 27 and 22 minus 583.2. After putting the values in this formula, you will get the dryness fractions. What is H2? It is 2682 minus 583.2 divided by its difference, that is 2148. So after simplification, you will get that is 0.977. So I obviously said that the dryness fraction will increase. So you can see initially it was 0.96, now it is 0.977. Next, we need to find the entropy S2. For that, we need the SF2 value, that will be equal to SFA plus SFB minus SFA divided by PB minus PA into P2 minus PA. So this SFA and SFB value you can get from the steam tables and then put in this interplotting formula, and you will get the final answer for SF2 value, that is equal to 6.9141 kilojoule per kg Kelvin. So take the difference of these two values, you will get the SFG2, that is equal to 5.241 kilojoule per kg Kelvin. So the final value of S2 will be equal to SF2 plus SFG2 multiplied with dryness fractions. So the SF2 value is 1.727 plus SFG2, that is 5.241 multiplied with dryness fraction 0.977. So finally you will get the entropy, that is S2 is equal to 6.817 kilojoule per kg. Now the change in entropy is equal to S2 minus S1. So what is S2 value? That is 6.817 minus S1, that is 6.522 minus 6.522. After taking, so after simplification, change in entropy, that is equal to 0.295 kilojoule per kg. So this is the change in entropy that is taken place in this example 4.10. I hope you understand. If you still have confusion, you can ask. Thank you so much for watching this video.